Hello everybody, my name is Robbie and today we'll be talking all about matter. I think it's a really cool subject. First, let's answer the question, what is matter? Well, matter is everything that surrounds us, everything that we could see, touch, smell, and feel. Well, matter is everything. There are 30 states of matter, but although scientists from NASA say that there are 6 or even 7 states of matter, we will focus on the 3 major states that people on Earth mostly come across. Those 3 states are liquid, solid, and gas. There are many examples of each state. Examples of solid may be ice, bricks, wood, car, and glass. Examples of liquid may be juice, water, milk, oil, or tea. Examples of gas may be steam, smog, oxygen, or helium. Now I wanted to show you how certain objects can change their state from solid to liquid and liquid to gas. I also wanted to show you how different states of matter can interact. In order to do that, I will show you 2 experiments. For the first experiment, we will be using an ice cube and a hot pan. When we put the ice cube on a hot pan, it starts to melt immediately. The ice turns from its solid state into liquid. Ice turns into water. Then, as the water heats up, it starts to steam. It turns from its liquid state into gas. There's less and less water in the pan, and in the end, it all turns into gas. And the pan is empty dry. Now, let's move to the second experiment. For this experiment, we will need vinegar, baking soda, a bottle, a balloon, and a funnel. First, we pour some vinegar, our liquid, to the bottle. Then, using the funnel, we put baking soda, our solid state object, into the balloon. Next, we gently put the balloon on our bottle, carefully not to spill the soda inside. Now, let's lift the balloon and let baking soda get inside. Baking soda on contact with vinegar releases gas which inflates our balloon. Thank you for watching, and I hope you liked it and maybe you learned something too. If you want, you can subscribe to my channel right now. Thank you and see you next time.
In this video you are going to learn what the 3 states of matter are, some examples of each state of matter, the characteristic properties of the 3 states of matter. The 3 states of matter are solid, liquid and gas. Let us look at solids. An example of a solid is your computer. The properties of solids depend on how the particles in solids are packed. In a solid, the particles are closely packed in fixed positions and cannot move anywhere. So, solids are rigid, cannot be squashed or compressed, have a fixed shape and a fixed volume. They cannot flow. Now let us look at liquids. An example of a liquid is water. Just as with solids, the properties of liquids depend on how the particles in liquids are packed. In a liquid, the particles are again closely packed, but not as closely packed as in solids. So this means the particles in liquids can move around each other. So, liquids are not rigid, but because their particles are closely packed as in solids, they cannot be squashed or compressed. They do not have a fixed shape, but they do have a fixed volume. Beware with that one, as many students think because liquids do not have a fixed shape, they do not have a fixed volume either. But they are wrong. If someone orders a pint of beer, they cannot make it 2 pints by pouring it into different containers. As you know, liquids can flow. Finally, let us look at gases. An example of a gas is helium. This is the gas in party balloons, because it is less dense than air and unreactive. Again, as with solids and liquids, the properties of gases depend on how the particles in gases are packed. Unlike solids and liquids, the particles in gases are not closely packed, they're far apart. As a result, gases are not rigid and can be squashed or compressed. They do not have a fixed shape nor fixed volume. They fill the whole space they are in.
Hi friends, do you know what I just did? I just took in the 3 states of matter: solid, liquid, and air, a gas. So are you ready to explore the 3 states of matter with me? And then we'll finish off with our top 3 questions on this topic. I'm sure you're familiar with the 3 states of matter: solid, liquid, and gas. When we look at something, our brain automatically knows, is it a solid, liquid, or a gas? In this video, we are going to compare these 3 states of matter in a more scientific way. So we'll compare them based on these 4 properties: shape and volume, compressibility, rigid or fluid, and do they fill their container completely. After that, we'll take a deeper look into solids, liquids and gases and compare them at a particle level. Let's start with solids. Do solids have a fixed shape? Yes. As you can see here, they have a fixed shape. This is a cuboid, this is a cube, this is a sphere, and my watch has an irregular shape. So for solids, the shape does not change. Now, do solids have a fixed volume? Again, the answer is yes, because the space that the solids occupy does not change. The volume is fixed, and we can calculate that volume. For example, the volume of a cuboid is length into breadth into height. The volume of a cube is a cube. The volume of a sphere is 4 by 3 pi r cube. Now, how do you calculate the volume of my watch, which has an irregular shape? That's right. By Archimedes' liquid displacement technique. If I dip this watch in water, then the volume of the watch is the volume of the water it displaces. I actually have a video on Archimedes' liquid displacement technique. So do check it out. Now let me pull out my watch before it stops working. Let's look at the compressibility of solids. Usually solids are difficult to compress. For example, I can't compress the things on the table here. So if I try to take this cube and I try to press it, I can't compress this cube here. There are some exceptions, like a sponge. We'll talk about that towards the end of the video. Are solids rigid or fluid? That's right. The correct answer is rigid because they have a fixed shape. Fluids are things that can flow. Now, do solids fill their container completely? For example, if I try to put this ball in this container here, does it fill the container completely? The answer is no. Let's add the properties of solids to our concept board. Now let's take a look at liquids. Liquids have a fixed volume but no fixed shape. I'm going to prove these 2 points to you with one single experiment here. For the experiment, I've taken water in this beaker, and as you can see, there's 100 ml of water here. Now I'm going to transfer this water into this container, this one, and this one. And you carefully take a look, what is the change in volume and shape of the liquid. So are you ready? Let's start. Now I'm going to transfer the water from this beaker into this bottle here. And then I'll transfer it to the glass here. Now let's transfer it to the measuring cylinder. So what is the final volume here? As you can see, it's 100 ml, and that's exactly the original volume. So what's the conclusion from our experiment? Liquids have a fixed volume. It was 100 ml all the way through. But they don't have a fixed shape. As you saw in the experiment, the liquid takes the shape of the container it is put in. Let's talk about the compressibility of liquids. If you take a plastic bottle like this containing water, if I try to crush this bottle, it looks like I can compress the water. So are liquids compressible? The answer is no. When I'm crushing it, am I really compressing the water? No, I'm compressing the air inside the bottle. Now if we fill this bottle completely with water, I need to be Superman to be able to crush this bottle. So liquids are almost incompressible, just like solids. Are liquids rigid or fluid? That's right. The correct answer is fluid. The word fluid means it can flow easily. As you can see, water can flow easily. So liquids are fluids. Do liquids fill their container completely? The answer is no. As you can see, in the glass and the bottle, the water only occupies its own volume. The rest of the container is air. So liquids do not fill their container completely. Let's place the properties of liquids on our concept board. Now let's take a look at the third state of matter, gases. Gases have neither a fixed shape nor a fixed volume. Just like liquids, gases take the shape of the container that they are in. One difference is the container needs to be closed. Now liquids have a fixed volume. But gases don't even have a fixed volume. The volume of the gas is the volume of the container. So for example, if I transfer this gas into a larger container, it will fill that container completely. Or if we apply some pressure and try to fit it into a smaller container, then the volume of the gas will be the volume of the smaller container. That brings us to the next point, compressibility. Gases are highly compressible. For example, I can easily squeeze this balloon, or I can easily crush the air in this bottle. Gases are usually stored under high pressure since they are highly compressible. That way we can fit more of the gas in a small container. For example, compressed natural gas is stored in cylinders at a high pressure. Just like liquids, gases are also fluids. They can flow. For example, if I open this bottle, can you see the air flowing out? Of course you can't, because air is colorless. But let's say it was a colored gas, then you would easily see it flowing out of the bottle. In fact, the term fluid is collectively used for liquids and gases. As we discussed before, gases are greedy. They want to fill up the container completely. For example, if this bottle contained a gas and I transferred it to a larger container, then the gas would fill up the larger container completely. Another example is when you open a perfume bottle in a room, the smell spreads to the entire room. So here the room is like a container to the perfume gas. So gases fill their container completely. Now let's pin the properties of gases to our concept board. We have discussed the difference in properties between solids, liquids and gases. But what makes something a solid, a liquid or a gas? For example, if you take water, it can exist in all three forms: ice, water and water vapor. Now it's the same substance, water. So how can it exist as a solid and a liquid and sometimes a gas? To answer this question, we need to zoom into matter and take a closer look. As you may already know, all matter, whether solid, liquid or gas, is made up of tiny, tiny particles. For example, ice, water and water vapor are all made up of the same tiny particles. That is the water molecules. Now let's compare the three states of matter at a particle level based on these 3 points: the distance between the particles, the force of attraction between the particles, and the amount of movement or the kinetic energy of the particles. To get a visual feel of things, I would like you to hold up your hands like this and imagine the tips of your fingers as particles. So are you ready? So this is what a solid would look like. The particles are tightly packed. The distance between the particles is very small. The force of attraction between the particles is very strong. So you have to apply a huge force if you want to change the shape of the solid. Even in a solid, the particles are moving, vibrating about their main positions. But their movement is less. Kinetic energy of the particles is small. Now this is what a liquid would look like. The particles are more loosely packed. The distance between the particles is bigger. The force of attraction between particles is weaker. In a liquid, the particles have more motion as compared to a solid. So the kinetic energy of particles is larger. And now this is a gas. The particles are very loosely packed. The distance between the particles is very large. Force of attraction between particles is very weak. In a gas, the particles are moving a lot. They are going crazy. The kinetic energy of the particles is maximum. Let's add the differences between solids, liquids and gases based on particles on our concept board. Now that we are done with the three states of matter, are you ready for the top 3 questions on this topic coming up for you right now? As we discussed, solids are incompressible. But if you consider a sponge, as you can see, we can easily compress it. So question 1 is, the sponge is a solid, then why is it compressible? Let me give you a hint. The sponge has holes in it. So what are you really compressing? Now let's look at question 2. I'm going to pour the sugar in this beaker into the glass here. Can you see the sugar flowing like water? And the sugar is taking the shape of the glass. So is sugar a solid or a liquid? The 3 states of matter that we've seen in this video are solid, liquid, and gas. Do you know that there are 2 more states of matter? So question 3 is going to be, what are the other 2 states of matter? Can we make this more interactive than just watching the video? So do post your answers to the questions, or if you have any doubts, in the comments below. And I promise to reply to all your comments promptly. I hope the 3 states of matter are crystal clear to you now. So remember, this is a solid, this is a liquid, and this is a gas. And here's the like button, which I'd like you to hit right now. Also, do remember to subscribe to my YouTube channel, and you can follow my Facebook page. Thanks for watching.